All right, then. Please download the file attached from the Google Calendar. Are you able to download?
No, sir. You have not given the access for those.
Yes, sir. Access is required.
Sir, completed, sir.
Okay.
Sir, can you see it? It is correct or wrong? It's our studio or not? For my confirmation, please.
Uh, okay. Sorry. Yeah, I think same screen. I think all of you get the same screen, right?
Yes, sir.
Okay. Right. Well, I think you can download the file.
No, sir. Sorry, sir. It's not downloaded.
Huh? How come? I have given access. Go to today's calendar.
Yes, sir, that table, right?
Yes, that is a
Yes.
empty course file is there, no? That one.
Yes, sir, visible, sir.
Okay, please do that.
Done, sir.
Very good. You are able to see, right?
Yes, sir.
Sir, is it the empty car dot csv?
Correct, correct.
Okay.
Okay. Okay. So first, all of you please create something like set. Okay. Here, whatever your name, that you please type. Okay.
Okay, sir.
For example, in D drive, you say my or program. Either in D drive or whatever it may be. Where you have to type? You have to type in the R Studio. You please open a new text. Can you do that?
Sir, it is showing cannot change working directory.
Um, it's coming. Just a minute. Let me. Just hold on. Okay, you do one thing. You execute this command, get WD.
Okay, sir, just a minute.
Just let me check what you're getting.
Yes, I got C drive.
I got
You
C
got it
drive,
in
sir.
C.
Yes, sir.
Huh?
C drive.
C drive documents.
CD documents.
Yes.
You can actually, this command will work. There is no issue at all. I don't know why you are getting like that.
So I also got C drive.
Okay,
Sir,
right now you are in C drive.
sir, do we have to
You,
make that folder in D drive? My R programs.
first of all, you have to create a folder in D drive called my R program.
Okay, so we'll do that. Wait a minute.
First, same file name. Okay, you
Got
have to
it, sir.
create that folder in D drive, and then you have set it.
Got it, sir.
Okay, you have to
Yes.
create that folder. Otherwise, you cannot do that.
Yes, got
Oh,
it.
how to create it, sir? Can you tell me, sir?
Go in the D drive and then make that folder name my underscore R underscore programs and just keep it over there and then do this one here, this command.
Whenever you are accessing a folder, that folder should be readily available. Please note that. Not only in this, anyway, some softwares will ask you the one command, then one message pops up that that folder is not available. Do you want to create? Okay, but some software they expect you to do it first, and then you do this. Okay. Done.
Done, sir.
Very good.
Yes, sir.
Okay. Now you please text this particular command, get working directory. WD means get working directory. Same command.
Done, sir.
Done.
Yes, sir.
Okay. So same thing you are getting.
Yes, sir. The same directory.
Very good. Same directory you must get. You are getting fine. Okay. So this area not required. 1 minute. 1 minute. Okay. My R is starting.
Excuse me, sir.
Yeah, please.
Sir, actually, my system is hanging because of the software. Can I please rejoin?
Yeah, please. Done. I think you know R programming, right? All of you?
No, sir.
No?
No, sir.
Okay, fine. For example, what is your directory? What is the current directory? Your current directory. What is your current directory?
So D drive.
You said my program something, right?
Yes, sir. My underscore. I made a folder in D drive and then I got this.
Okay. Fine. One more thing. To do one thing. I'll share one more. Just hold on. Huh? Okay, anyhow, just for information, we have done already multiple regression on Excel, isn't it? We have to do it on R. We'll do that. Before that, what are the assumptions of R? What are the assumptions of R? Do you know? I already mentioned some of the assumptions. What are they? Those assumptions. Do you remember? Am I audible?
Yes, sir, you are.
Yes, sir.
Yeah, okay. Fine. What are the assumptions?
No autocorrelation.
What are the assumptions? Anybody remember the assumptions?
No, sir.
No. Okay, first of all, the apples should follow normal distribution with mean 0 and some variance sigma square. And that variance must be constant for every error at every data point. It should be constant. So that is called as homoscedasticity. Then what is heteroscedasticity? Homoscedasticity means constant variance at for every error. Okay. Then what is heteroscedasticity? What is heteroscedasticity? Come on, come on. What is heteroscedasticity?
The variance is not equal.
Not same. Not same at every error. Okay. Errors are normally distributed with mean 0 and some variance. That variance you can call it as sigma square. Okay. And this variance sigma square, the error variance, system is very slow. Variance is, the error variance is constant. If it is constant, what do you call it? Error variance is constant. If it is constant, we call it as homoscedastic. Homoscedasticity. The state being constant variance is called as homoscedasticity. Okay. If the variance is not constant, then what do you call it?
Hetero, sir.
Heteroscedasticity. Okay. It is known as hetero. Right. If you want to, you have to check whether the errors are normally distributed or not. Similarly, you need to check whether the variance is constant or not. This is also very important. Okay. Understood? So, for doing this, we have various tests. And those tests are Gross-Pagan BP test for heteroscedasticity. Do you understand this? I just now told you what is homoscedasticity. Okay. This is useful for what? This test is useful for to test whether the error variance is constant. Okay. This particular test we do it to see whether the variance is constant or not. Okay. So what is the hypothesis? This is going to be the hypothesis. This is going to be the H naught for that particular one. Okay. H0. What is the H0 for this test?
The error variance is constant.
The error variance is constant. Right. Durbin-Watson test. This is also one of the assumptions. The errors should not be correlated. Autocorrelation, what do you mean by autocorrelation? Any idea? What is meant by autocorrelation?
To check the independency
of
the variables.
Autocorrelation.
Whether variables are the error values are independent to each other.
No, actually, to demonstrate this, okay, I'll do one thing. Just hold on. Some issue is there. Please hold on. Do you remember on the other day, what is the file name I have sent you? I've shared one file. What is that?
For the cars, it is, sir.
No. Actually, in the last week, we have done multiple regression. We have done, right?
Yes, sir.
Yes, sir.
Okay. What is that file name?
So SLR, you shared something.
I think multi-reg something. MLR October 30. Correct. Let me open that file. It's very annoying. Okay. Fine. I'll share this file. Is this the one which we have done in the last week? Are you able to see the file?
Yes, sir.
Yes, sir.
Yes,
Is it
sir.
not the file we have used last week?
Yes, sir.
Very good. Okay. So fine. Let me repeat this. Copy this sheet. Okay. I will delete all this. We close this. Okay. Are you able to see it now properly? It's fine?
Yes, sir.
Okay. Fine. So this is also not required. So what is the model revenue? So let us predict this revenue forecast. Let me write this as revenue forecast. Okay. So how do I get revenue forecast? How do I get it?
By putting the value of TV ad and print ad. Like first we put 5 and 1.5 and
You know, this particular one. Let's see. Okay. Now, in place of TV ad, what number we have to give?
5.
5. Okay. In place of this, 1.5. Correct?
Yes, sir.
Yeah. What is the predicted value?
96.63.
This is the predicted value, right?
Yes, sir.
Okay. If you repeat this particular one, then these are the values. Is it right?
Yes, sir.
These are the values, isn't it? Okay. Now, what is the error? Error is equal to actual. What is actual?
96.
Revenue minus revenue forecast.
Correct. 90 minus revenue forecast. This is the error. Similarly, the errors are here like this. Correct?
Yes, sir.
Now, if these are the errors, let me copy the errors into some other sheet. Paste to special. Okay, these are the errors, right?
Yes.
All right. Let me increase the font size. You're able to see clearly?
Yes, sir.
Yes, sir.
Okay. So, fine. If this is the error, how to find correlation within this? You have to find correlation within this. Within this means for the error. Is this error related to this? Is this error related to this? And this one related to this? Like that you have to find. What should be the total error? What should be the
Zero.
total error? It
Zero,
should be
sir.
0. Correct? Due to rounding issues, you may get some value, but it should be theoretically 0. And you will get it, of course. Okay? Oh, no. Are you able to see this?
Yes, sir.
Yes, sir.
Okay. Right. So therefore, in that case, what I need to do is this error related to this. Control Z. That means which error is related to this? This one related to this. Now, this error is related to, we want to test whether this error related to this one, isn't it? That implies we need to, I'm sorry. What is the error previous to this? Not forwarded error. Error should be taken always backward. Okay, isn't it? Whether the previous value, okay, I have one question. How is the stock market today?
So it's falling.
It's falling.
Yes, sir.
How the market closed yesterday?
Positive. I mean, no, flat. It was almost flat. It was.
Okay. Just tomorrow, can you make a forecast, the direction of the market, whether it is going to be positive or
So it depends. Today it is going negative because of international issues, sir. I think so.
okay. That means, is it not today, somehow will have effect on tomorrow?
Yes, sir.
Yes, sir.
Yes, definitely.
Like yesterday had some effect on today, correct?
Yes.
Yes, sir.
So that means 40.41 can be related to this error. Whatever is the effect there, that difference that you got between the actual and forecasted, that error is this error may be influencing this particular error. And similarly, this error may influence the next day. Next day means this one, correct? So in similar manner, these values this should come. Array, no, this is not working or what? Yeah, this one should affect this one. Okay. So you can do this way, or what I'm telling you is whether the lag one errors are getting that is influencing the next one. Today is being affected by yesterday or not. This is what we are trying to do, correct? Okay. So these are the errors. Let me once again copy these errors here. Will be okay. So these are the errors of today. Errors 1, I call it. What are the previous day errors? Do you have any error previous for? Okay. Yeah. Do you have any error previous for 0.63, minus 0.63? Do you have?
No, sir.
No, sir.
Do you have data for previous day? You don't have, correct?
Yes, sir.
But what is the data for minus 0.41? Do you have previous?
Yes, sir.
Yes, sir.
Yes,
Minus
sir.
0.63.
Minus 0.63. What about 0.66 previous day?
Minus 0.4.
Minus 0.41.
That means these values are, if I copy and paste them here, are you able to see?
No,
Yes,
sir.
sir.
Some
Sir, it's
disconnect.
overlapping.
Sir, it's overlapping.
Overlapping. Yeah, that's what. Okay, now it's fine.
Yes, sir.
Yes.
Okay. You don't have value here. So therefore, let me remove this particular value because I don't have. Now you have two series. When you have two variables, can you find correlation? When you have two series, can you find correlation?
Yes, sir.
Okay. What is the correlation? What is the formula for correlation? Excel formula. Pearson is a function. You can calculate correlation using that. Okay. Okay. How much is this correlation? Is it not close to 0?
Yes, sir.
Yes, sir.
Yes. Going back to our slide. Yeah. What is saying here? Whatever the correlation that we have obtained, that correlation is known as what? Is it not self-correlation? It is. Self means auto.
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay. That's the reason it is called as autocorrelation. Correlation and autocorrelation. Okay. Correlation you can find out that is a correlation between two different variables. But autocorrelation is the correlation within that variable. I just demonstrated how you can calculate autocorrelation. Correct? Okay. So to test whether autocorrelation is 0, what you need to do? You have to take the hypothesis that
So the error variance must be constant.
no. I'm sorry. The autocorrelation of error is 0. This is what we have to test. Do you understand?
Yes, sir.
The autocorrelation of error should be 0. Okay. One more assumption I told you. What is that assumption? The error should follow normal distribution, correct? The distribution of errors must be normal. Okay. Then, what is this multicollinearity? Multicollinear. Some of you must studied mathematics. What do you mean by collinear? Do you remember the concept of
On the
collinearity?
same line, points are on the same line.
On the same line, correct? On the same line or same plane. If you have multiple dimensions, we call it as plane, correct? Is it right or not? Am I audible?
Yes, sir.
Yes, sir.
Sir,
Yeah. What is that multi-dimension? In multi-dimensions, instead of line, we will have plane, correct?
yes, sir.
Okay. So in multi-dimensions, instead of line, we have plane. So if all the variables on same plane, then we call them as collinear, right? What do you mean by that? If they are on the same plane, what will happen? Or same line, what will happen? Is not the correlation is perfect? If all points are on same line, what is that? Is not correlation perfect? You do one thing. I give you one exercise. What is that? Let me stop presenting this. If you want to understand this concept, try this one. Okay. See, this is X value and this is Y value. Okay. Now tell me randomly some numbers, X values, single digit or maximum up to 15. Tell some numbers.
8, 7,
You said 8. Next number?
5,
5. Next?
10,
10. Okay. Next?
7,
7. Next?
3.
Enough. Okay. And what I do, this Y value is equal to 12 plus 3 times of what happened to this? 3 times of this. So don't you say that this X and Y are perfectly related now?
Yes, sir.
See, every value, it is 12 plus 3 times of this number. This also. What is the 3 times of 5?
15.
15 plus 12.
27.
Okay. 3 times 10. 10 plus 30. 30 plus 12.
42.
Right. Very good. So, if you plot these numbers with scatter plot, if you plot these numbers, okay. Are they not perfectly on a line?
Yes, sir.
Yes, sir.
They are perfectly on a line, right?
Yes, sir.
Okay. So they are perfectly online. If they are perfectly online, what will happen to the correlation?
Sir, 1.
You can check that. You can check the correlation. What is the formula for correlation? Pearson. Pearson of this series, comma, this series. You will get correlation. What is that?
1, sir.
1. Is it not perfectly correlated?
Yes, sir.
If the two variables are on the same straight line, it means correlation is 1. Isn't it? Is that right?
Yes, sir.
Yes. Yes, sir.
Okay. So using that concept, let me go back to our slide. Okay. So multicollinearity means correlation between independent variables. What happens if there is correlation between independent variables? If there is correlation between independent variables, then what will happen?
Sir, then it will be 0.
What is 0?
Sir, correlation would be 0.
No. The correlation between independent variables is positive, is not 0.
Okay.
Is not 0. That means if two variables you have, there is a perfect correlation between them. If there is a perfect correlation, for example, in the previous example, I told you y is nothing but 12 times, 3 times of that x variable plus 12. If that is the thing. If two variables are perfectly correlated, you can have some kind of equation between them like this. Correct? If the correlation is perfect, that is 1, there exists some regression equation with which you can get the other one perfectly. Is it right or not?
Yes, sir.
If there exists a perfect correlation, that is 1, then if you know one variable, you can get the other variable. You know the equation, you know one value. What is the other value? You can tell easily. Isn't it?
Yes.
If you have one variable, you can get the other variable using the equation. That's what I'm saying. You can get it now?
Yes, sir, we can get it.
We can get it. So, then in that case, if you know one variable, is it required to know about the other variable? Will the other
No, sir.
variable contribute any new information?
No, sir.
No, sir.
That means the information given is useless. It will not contribute anything. It will not contribute any new information, isn't it?
Yes, sir.
If the variable does not contribute any information, new information or extra information in the regression model, when there are many variables, don't you drop such useless variable from the regression model?
Yes, sir.
When it will not give, see, suppose you said yes. If whole class says yes, of course everyone knows. Then everyone says yes. Then it gives noise only, but information is same, correct? Isn't it? Why no response? Am I audible?
Yes, sir. You are audible, sir.
Yes.
Why don't you give response? If answer everyone in the class knows the answer, and if someone says yes, and with chorus everyone says yes, am I getting any new information or only noise?
No, sir. Only noise.
Only noise. How to reduce noise? I had a request, only one of you please speak. Correct?
Yes, sir.
Because anyone in the class will get the same information. In the same manner, if there are multiple variables and which contribute same information, why don't you drop them?
आपने कुछ नारकली का बोलना था कि गगन नारकली के साथ करें.
What is happening? It's being recorded.
Earphones.
63. Okay, fine. So, if you want to control the noise, or otherwise, if you want to remove the superfluous information, what you need to do to make anything simple?
Sir, don't consider the noise. Only one input is sufficient.
That means whatever the variable, we keep one. If two variables are related, we keep one variable and drop the other variable. Isn't it from the model?
Yes, sir.
This concept is known as multicollinearity. Okay? This concept is known as multicollinearity.
So, sir, so this multicollinearity is applicable only if the correlation is perfect. I mean, the variables are perfectly correlated.
Independent variables. Please be
Independent
sure. Okay? Independent variables. If at all the independent variables are correlated, you consider only one variable and drop the other variables which are related to this particular variable. Correct?
Okay.
Is it right?
Yes, sir.
Whatever the variables that are related to one of the variables that you are considering the model, drop other variables. Because already the representative of all those variables is there in the model. What this variable contributes, what the variables that are being dropped contribute is same. Are you getting my point?
Yes, sir.
So why do we drop this variable? Because when there are many variables, it is going to be very complicated model. Have you heard of a term called parsimony?
No, sir.
Parsimony. Do you know?
No, sir.
No idea? Parsimony? Parsimony means very simple. Keep it few. Okay. If there are so many variables, you definitely there can be multicollinearity. Implies some of the independent variables are related. So therefore, you don't consider all those variables. You drop the variables which are correlated with some variable in the model. Okay. This is called as multicollinearity. So all these things can be tested. So which particular one is used for the multicollinearity? Which one we use for multicollinearity? Which concept? Which one we use? What is that is known as? VIF factor. Okay, VIF. The VIF is useful to check whether the variable is correlated with some other variable. So this is what we are going to study in multiple regression. Okay. So anyhow, we have that particular one, and tomorrow I'm going to run this particular exercise on R, whatever the file shared to you. Okay. I will share some other file also today. We will do both. Is that fine?
Okay, sir.
Yes,
Okay,
sir.
sir.
Yes, sir.
Okay, give your attendance.
So,
Yeah, please.
sir, I wanted to ask that in my SIS, I have not given attendance for a day, and for the same.
Yeah, you already mailed me. You
Yes.
please keep it pending, no? Okay, because I have already submitted the attendance. If you have any issues of attendance at the end, I will consider. Right now, I cannot edit the attendance already submitted. Okay? Don't worry about that attendance.
Okay, sir.
Okay? So, Satyajit, I think you also have given me mail, right?
Yes, sir.
Okay. Please note that once I submit the attendance, I cannot edit it. Submission means no non-editable. I have to once again inform the office, and they will see the mail, and they once again give the edit mode to me. Then I have to correct it. So it takes long time. But
Sir,
anyhow,
if any further problem is there
if
in
you have
attendance,
any issues with attendance at the end, I will take care. You please mark these mails to me. I will correct at the end. Okay.
thank you, sir.
But don't confuse the. I want to discourage this giving mails for attendance. Okay. But anyhow, if you have any serious issue, I will take care at the end. Don't worry about
Thank you, sir.
it. Okay. Be attentive while giving attendance. So if we accumulate so many mails at the end, that is also another problem. Okay. Right. Any other questions? Any other?
No, sir. Thank you.
No,
That's
sir.
it? Okay, fine. I am going to share another file also with you. You please work on this, and tomorrow we are going to do that. Right?
Sir, two
Yeah.
files are also there in the Meet link. I think those are notes, but we cannot access them.
Which one is that?
Sir, it's note BA2. It's a doc file, sir.
No, I don't know what that file is. Okay, but this file you please access.
Yeah, okay, sir.
Only this one. Right? Okay.
Thank you, sir.
Okay, right.